8. Today we are doing Pythagoras' theorem again. We should be getting very good at this by now because we've had lots of practice. But this time we are turning our Pythagoras problems into word problems. So the tricky part is the very start part where you have to try to turn what is written into the question into a diagram that you can use Pythagoras' theorem on. And each question can be slightly different. So it does say here, if a question does not have a diagram, draw one, capital letters, exclamation mark. You always should have a diagram so that you can see what it is you are trying to find. So question 1, how long is the diagonal of a square that has a side length of 5 centimetres? So here is my diagram. We have a square, just roughly, it doesn't have to be perfect. Here is my square, all those sides are the same, and they are all 5 centimetres, and they will be right angles in the corner. I am trying to find the length of the diagonal. So if I draw a diagonal which goes from one side to the other, that's what I'm trying to find. I'm just going to be using the right angle triangle that I've just made. This one I'm drawing in red, this right angle triangle. Now the 5 centimetres on the bottom, it would also be 5 centimetres on the side because it's a square, remember. So if I have the two sides that are next to my right angle, that means that I'm trying to find the hypotenuse. So we're going to use our hypotenuse formula. H equals square root of a squared plus b squared. Subbing in, we would get 5 squared plus 5 squared. And then putting that in our calculator, we get 7.1 if we're doing one decimal place. 7.1 centimetres is the length of the diagonal. Okay, question 2. A 4-metre ladder leans against a wall. Okay, so when you have a wall, this is my very fancy wall here, just a straight line. And you'd need the ground, so the ground's going to come across the bottom. And the ground and walls are usually at right angles, otherwise something is wrong. So the ladder would have the bottom of the ladder on the ground and it's going to be leaning against the wall. Okay, so this sloping side is the ladder and it is 4 meters long. Then it says the foot of the ladder is 90 centimeters from the wall. So remember the bottom of my ladder is down here and the wall is where the right angle is. So this is 90 centimeters across the bottom. Find the distance that the ladder reaches up the wall. Give your answer in centimetres. So I'm trying to find the third side, which will be this one over here. Okay, now that's going to be one of the shorter sides because it is next to the right angle. So it's going to be the A formula. A equals square root of h squared minus b squared. But there's one other trick with this question, and that is that one of the sides is in metres and the other side is in centimetres. In the question, it says to give an answer in centimetres, which means I want to change that one. 4 metres, you times it by 100, is the same as 400 centimetres. So that is going to be my hypotenuse, the longest side, and the 90 is going to be the b. Let's put that into our formula. Square root, the hypotenuse is 400 squared minus the shorter side, which is 90 squared. Square root 400 squared minus 90 squared is, and we'll do one decimal place again, 389.7. That will be in centimetres. Question 3. A speedboat travels north for 8.7 kilometres and then travels a further 11.2 kilometres east. So to draw a diagram for this, you need to know a little bit about a compass. So here is my little compass. The arrow that is pointing to the top is what's going to be north. Then directly opposite that is south. And then to the right is east. And then to the left is west. So north, south, east, west, or never eat soggy Weet-Bix is one way to remember it as you go in a clockwise direction. So using that compass, our speedboat is going to travel 8.7 kilometres north. So it's going to start down here, and north means it's going up. So it's going this way, you put a little arrow on the end because it's going that way, and it's going 8.7 kilometres. Then it turns and it's going to be going east, which is to the right. So it's going to go to the right now, and it's going to do that for 11.2 kilometres. If the boat then travels straight back to its starting position, so it goes all the way back to the start, how far will it need to travel to get back to the start? The right angle would be in here, because between the going north and then the going east, those would be at right angles. Finding my missing side, I have the 2 next to the right angle, so I'm trying to find the hypotenuse. The formula for hypotenuse is the square root of a squared plus b squared. The a and the b that I have are 8.7 and 11.2. Putting that in the calculator, to 1 decimal place, we would get 14.2, and that would be kilometres. So they have to travel 14.2 kilometres to get back to the start. Okay, so the Pythagoras theorem part is the same, just getting those diagrams right to start with. So let's practice that in our workbook now on pages 9 and 10.